Resume recording. Okay. Okay. So if I walk into a classroom, I sit down and I open a book. How do I inverse that? So these, like the first two things, we're doing one operation, right? Now we're doing, I think, three different things. So they're trying to get at like, what do we have to do to inverse things?
Open the book.
Okay, so I heard two things, and I think they were both talking about the book. So if we open the book, we want to close the book. The next thing we're going to do is stand up. And then the last thing we're going to do is
Walk out of the classroom.
walk right out of that classroom. That's it. So when we inverse things, like if we walk into a classroom, sit down, or open a book, right? Or getting dressed, I guess, is another example. If I'm going to put on like my socks and then I put on my shoes, I have to take off my shoes before I take off my socks. Unless I'm some sort of magician or have some little gimmick. I don't know. But most of the time, you're going to take off your shoes first, right? So when we inverse things, we're doing things kind of backwards. Open a door, turn on the lights. You got to turn off the lights and then close the door. Okay. These ones. So something like f of x equals 3x minus 1. Oh, I forgot when I do it on here. It's not on here. Ooh. This is one I got sharing. Okay. I can annotate with this thing though. If I have something like f of x equals 3x minus 1, who's first? Brian?
For this, I got, so f of negative 1x, or the power of negative 1x, I think it was, equals x plus 1 over 3.
Okay. So how did you find it?
Honestly, I just kept looking at the notes and trying to figure it out my best. This stuff's kind of confusing to me.
Okay, so instead of f of x, I'm just going to write y equals 3x minus 1. Just to simplify it out a little bit. And I said something about swap and solve, right? So what am I swapping?
You're going to swap out the y and the x, I think.
So my y becomes a
x. So it'll be x 3y minus 1.
Yeah, there you go. So x equals 3y minus 1. And now what am I doing?
Look at the notes again.
Solving for
y?
For y, that's it. So I'm going to solve for this thing.
So then I honestly just did my best guess for this one. So you have to divide each side by y to get rid of it, or no, we have to solve it.
So we're solving for it. We want to get this thing by itself.
I really don't know.
So we see
walking me through this one, and then I can.
So if you were to plug something into y, right, you would multiply it by 3 first, and then you would subtract the 1. So we want to work backwards. So the last thing I just said was subtract 1.
So you're going to add 1.
So we want to add 1 to each side. So maybe a different color. Small one. So we're working kind of backwards of what we see there. And so this is what x plus 1 is what 3y.
So then I still don't know how you get rid of the y. Divide it out at this point, or
so we don't want to get rid of the y, but we do want it by itself on one side.
So then you would divide each side by 3.
Yeah, that's it.
Okay.
I kept saying y. I was like almost there. 3y, and we're dividing both sides by 3. I don't have much room here, but if I do that, that's going to put my x plus 1 over 3, and I have the 3y over y. That should give me on this side a y.
Okay. So wait, how the hell did I get the right answer with the guess?
I don't know.
Okay. Okay, so that makes more sense now.
So that's it. Maybe a little bit more formalization, like you're saying. We want to say maybe f inverse of x is what? X plus 1 over 3.
Oh, so I think what was confusing me is you put the extra the y for the variable, and that wasn't what I did. Okay, never mind. I'm complicating it for myself.
Okay. It was 53, 55.
I apologize. I have a question.
Yeah.
Why did you okay, like the problem was y equals 3x minus 1. Why did you switch the x and the y? Like why did you?
That was the step that we do to find the inverse. So the inverse basically swaps your x and your y. Your domain becomes your range becomes your domain.
Okay, gotcha.
We want something so that when we plug in something for y, it gives us like the correlating x, right? That's what our inverse does. And so when we swap these two variables, we're making that thing the inverse at that step.
Okay.
And so now at like this step here, right? This is actually our inverse the second we swap it. The only other thing we have to do is like solve for y, because we want y to be the variable as that we set our inverse to.
Okay. Thank you so much.
Okay. Questions? 55 is 2x to the third minus 5. And so the first thing I'm going to do is, I don't want all that. Can I get this? Like, let me try something. No, that's not what I want to do. No, it's not doing it. Whoops. Yeah, I messed it up. All right, so I was trying to get rid of the picture. Now the picture is the only thing I see, and all I see is myself. That's annoying. All right, so we have something like 2x to the third. Just it on here. Minus 5. Who's next? Josh. I'm probably going to get rid of that f of x first.
So I ended up with 2y cubed minus 5 equals x. So I just switched those x and y's, and then I did a plus 5 to either side.
And so you swap the x and y, and then you did a plus 5. So it should be x plus 5 equals what? 2y to the third?
Equals x plus 5, yeah. And then I divided both sides by 2.
So one side, I'm going to swap the sides now probably. Y to the third equals x plus 5, and we're dividing both sides by 2. So this entire thing sounds like you put it over 2 probably.
Yeah. And then I took the square or the cubed root of y third and the cubed root of x plus 5 over 2, which gave me y equals cubed root of x plus 5 over 2.
Yeah, so like everything in this problem is pretty much, I want to say like kind of the same steps as that previous problem, right? Up until this point. So we need to get rid of a cube root. So how do we do that? Or we need to get rid of a cube. So how do we do that? We take a cube root. That's what I meant to say. And if that happens, I think you're saying we get y on this side. We cube root a cube. And this just stays here with the cube root of what, x plus 5 over 2?
Yeah.
And so maybe just to formalize it, we're writing f inverse of x is equal to, and I don't want to rewrite this thing over again, but I'm going to rewrite that thing. So the cube root of x plus 5 over 2. I know that denominator is not rationalized or whatever, like we were doing back in the day when we were doing radicals, but that's fine. Questions about this one? Okay. Are we getting these? Swapping, solving. So this was, I don't know, stuff that we did a long time ago, right? When we solved for a single variable sort of thing, trying to get those sorts of things down. And wasn't trying to scare you, but I'm pretty sure I did say back then, like this stuff is going to come up again and again, right? So if you're not understanding it then, like, got to ask questions at some point. So y equals 1 over x. So I think, what, 54 was the one that we didn't have to do, right? Yeah, okay. 1 over x minus 3. If I'm looking at this, Vanessa, did you get this one?
I wasn't sure how to do this one.
Okay.
Would you divide both sides to get x by itself?
All right, so the first thing I want to do is swap it.
Okay.
And so swap my x and my y. Now I want to solve for y. So what would be the first thing I want to do?
Would you divide it?
So it's the last thing that you're going to do if you plug in a y. So if I plug in a y, I'm going to take 1, I'm going to divide it by like let's say y was 2, right? I divide it by a half. And then the last thing I would do is subtract 3. So I want to work backwards now. And so the last thing I just said was subtract 3. So if I want to undo a subtract 3, how do I do that?
Add 3?
Yeah, so I want to add 3. And so we have something like what? X plus 3 equals what? 1 over y.
Mm-hmm.
The kids are extra rambunctious today out there. And we want to solve this thing. So I have something like 1 over y. How would I get rid of that 1 over something? There's a few different ways to do this at this point.
Would you multiply it?
Okay, so I want to multiply it by what?
Would you multiply both sides by the 1 or the 1 over y?
So if it's dividing by y, how would you get rid of this y on the bottom?
Multiply y?
Yeah, I think you have the right idea. Yeah, that's it. So if we multiply both sides by y, this might look a little silly because it might feel like you're going backwards for a second, but you're getting in the right direction. This becomes y times x plus 3, and this is equal to, this thing over here is y over 1 times 1 over y, or y over y. What is that giving me?
Would it just become 1?
Yeah, so this is just 1 over here. So now we look, we have y, and it's being multiplied by this thing, and we get all that's equal to 1. And we want y by itself. So we see y. This operation between y and that other thing is multiplication. So how do I get rid of multiplication?
Divide?
I'm going to divide this. I'm going to divide it by what? What's there that I don't want?
The y?
No, I want the y to stay on that side. I want y by itself.
Would it be the x plus 3?
I'm dividing by x plus 3 here. Oh, there's extra line there. There you go. And if I divide it by it over there, I also got to go divide by it over here. So I'm running out of some room. I think I'm going to erase some older stuff. So on the left side, I have y. I have an x plus 3 over an x plus 3. What is that going to be?
They cancel each other out.
Yeah, that would simplify out. So I should have just y on that side. And on this side, I have what?
Would it be 1 over x plus 3?
That's it. Questions about this one? So I know there's a few different ways you could probably do this. I think you could do this with like the butterfly thing too, right? Maybe on this step right here. If we have something that looks like 1 over y here, I think, right? 1 over y, we could also look at this as x plus 3 over 1. And we could probably do the butterflies at that step.
I have a question.
Mhm.
I always got a question. Okay, when you had the x plus 3 in parentheses equals y over, 1 over y, and I understand that you have to multiply y from both sides, right?
Yep.
And then when you end up having the y on both sides, I don't have to distribute that y. No.
So, oh, okay. So I think I see what you're saying. So at this step, when you say something like y equals x, was x plus 3 equals 1?
Yes. The 1 over y. Cause you end up multiplying y on both sides.
Mhm.
And I understand that when you have to cross out both y's on your right side, and that gives you 1. But when you have the y in parentheses, y parentheses x plus 3, I don't have to distribute that y.
Like distributing it here,
Yeah.
you can, but I think you want it by itself. And so if we did that, we would have something like x plus xy plus 3y.
Yeah.
And that's not going to help us get a single y by itself. You're getting like 2 y's now. There's 2 y's in the equation.
Okay.
And so if you keep it factored out, it's easier just to divide by that x plus 3.
Okay. Okay, gotcha.
So getting a y by itself, and sometimes you might end up with something that looks like this. You might be going the other way. You might end up with xy plus 3y, 2 terms of y. And the strategy usually there is to factor out the y. So sometimes we actually do end up with something that looks like this, and we have to go and factor out the y.
Okay.
Because usually if you solve for a variable, it's getting everything with the variable to one side, everything without. And then we factor out the y and divide. I mean, it's a valid operation, but it's not the direction that we want to go in, sort of. And I kind of know the direction we want to go in because I've been doing this stuff for 12 years or so, you know. So I've definitely had a little bit of practice. But what was that, 67?
Yes.
Okay, so we have to add the 3. So it's like 1 over x plus 3, right? 87. Same approach. I see y equals cube root of x minus 5. Alondra, did you get this far?
No, I didn't. I'm actually trying to do it right now because I had to go downstairs real quick.
So I'll ask you. So if this is my original equation, how do I find the inverse? What's the first thing I do?
Use substitution.
How are you talking? What do you mean substitution?
Or just try to find the y, like change fx to y.
So I got the f of x, I changed it to y, but what do I do now with my variables?
We changed the x and the y.
Yeah, so the y becomes the x becomes the y. Okay. So if I'm plugging something into my y, the first thing I would do is subtract 5. And then I would take the cube root. So if I want to do that backwards, what's the first thing I should do? No hush.
We like, do we raise both sides of the equation by like 3?
Yeah. So this is a cube root. We want to get rid of that cube root. So in order to get rid of that cube root, we're raising both sides to the third. So if we look at this on this side, I believe I have x to the third. On this side, you raised it to the third. Hopefully you did that so that it gets rid of that cube root. And then
we would move the 5 to the other side, right? And it would
Yes.
be positive 5.
Yep, so it should be what, x to the third, what, plus 5,
Plus
is that what I'm
5.
hearing?
Yes.
And then what?
And that would be the answer, right?
Yeah, that's it. So f inverse of x is equal to x to the third plus 5. I'm running out of room here. I'm gonna have to delete some stuff. All right. Is that it? Well, they asked the domain and the range, huh?
Yeah.
All right, so let's do the domain and range of, I don't know, f of x. Ooh, pen this time. F of x, let's do domain and range. And let's do this one with the domain and range in green, maybe. All right, so my original function looks like cube root of x minus 5. What is my domain for a cube root? Do we remember what those things look like?
It's minus infinity plus infinity.
Yeah, so the cube root, if we remember what they look like sort of like that, right? So the square root was the thing that we had the problems with, right? The square root was the one that looked like that and only had the positive. The cube root was fine. We could throw negatives in a cube root, we get negatives out. So this is all real numbers, minus infinity to infinity. That's my domain of that thing. What about my range?
Wouldn't it be the same thing?
Exactly. Yep. Minus infinity to infinity. Yep. What about for my inverse?
F minus 1 of x.
Yeah, so x to the third plus 5, I think, is my
Yeah,
inverse.
it's the same thing, minus infinity plus infinity.
So one way you can do it is you can take your range of that one, and this should be your domain of this one. This one's probably a little bit easier. You can look at the function and just tell. But if we didn't even solve the function, right? If we just had the domain and range of my original, all I'm doing is swapping those two sets. Like my original is like, what is the thing that takes x and gives me a y? The inverse is a thing that says, what is it? I take a y and that gives me an x, right? I'm just swapping my variables.
Like it's the
Swapping
opposite
my
for the first one.
I know it's all the same here, right? It's all minus infinity to infinity. So maybe that point's not a good point with this problem. But if I didn't know, all I'd have to do is swap those two things. Questions? Even looking at this, x to the third plus 5, if I want to do my domain and range the old-fashioned way, right? That looks like this function. Hopefully I can draw it on here without getting in the way of my picture. Here we go. We know what a cube function looks like. raised up 5. Maybe I should have raised it up 5 or something, right? But we know it goes from minus infinity to infinity domain, right? And the x values and then the y values. Questions about this one? No? Okay. I gotta scroll on this one. So exit out of this. That was a 87-101. Use the table of f of x to find a table of f inverse of x. Identify the domain and ranges. All right, so let's start off with the domain and range of this thing. How do I write the domain of this thing? So who was next? Fernanda? Are you here? There you go.
I'm not too sure about this one, but
So the domain is which values?
the x, right?
Yeah, the x values. And so I only have single x values. So what I should really be writing is just these set braces. So what x values am I talking about here?
You have
What x values do you have?
0, 2, and 4.
0, 2, and 4. And just those x values are the ones that are defined.
Mhm.
What about my range values?
0, 4, and 16.
And this is for my f of x function. Okay, so if I want to do my f inverse of x, how would I fix this? What would my domain be for my inverse?
Hmm. I'm not too sure.
So if this is the domain and range of my original function,
Mhm.
how do I find the domain of my inverse? Just do it in different colors.
Mm,
And so if I let my x's be y's and my y's be x's, what does that do to my domain and range? If I swap my variables, what does that do to my domain and range?
Does it?
If I swap my x's are going to become what?
Are you basically just like swapping them?
Yeah, that's all we're doing.
Oh, okay.
0, 4, 16 is my domain, and what, 0, 2, 4 is my range?
Okay.
Yes.
Sorry, I wasn't sure.
And so if I want my x and I want my f inverse of x here, what values am I going to put in for my x?
Would it still be 0?
Yeah, we're still putting in 0.
0, 4, 16.
4, 16. And my inverse is going to be what?
0, 2, 4.
Yep, that's it.
Okay.
Questions about this one?
Teacher, how about the domain? The domain as, I mean, like the infinity plus infinity. Here it's going to be 0 plus infinity, right?
So if we go 0 to infinity, right? That would include numbers like 1, right?
Yes.
Well, if we did this with 1, what can you tell me? Where does 1 go with this function?
It's between 0 and 2.
Ah, but they're only giving us a table. So you're assuming that it's a square, but right, but it could be something slightly different.
Yes, because for me, I did minus for the domain, I did minus infinity plus infinity. For the range, I did minus infinity plus infinity. Then, but I'm not sure.
My dogs are barking loud. Sorry. I'm about to throw him a bone or something. So 1 is actually undefined with this table. If we try to throw 1 into this table or get a value of 1 from this table, it's undefined. I know you're probably making like the inference like this is just a square function or something, but this is like one of those instances where we can only assume what's sort of given to us. And we don't know for a fact that this is a square function. So like things with 1 or things like 5, right, are undefined.
But in this case, teacher, when you ask for the domain and the range, just we need just to put them as we did right now. Just we swipe the x and the y's, and then we need to give the domain and the range.
Yeah, so for this one, it would just be like a set builder sort of thing with just the numbers 0, 2, and 4. Those are the only numbers that we can plug into this function.
Yes, but my question is it we need to write like minus infinity plus infinity or 0 infinity or whatever. This one is what I want to say.
So if you tell me something like 0 to infinity though, right, that's not the same thing as just 0, 2, and 4.
Yes.
This includes the numbers 1, this includes the numbers 5, this includes the numbers like 1.5, right?
The whole thing, the whole positive.
Yeah, so that's a whole range of numbers. These are just those specific numbers. This set like consists of 3 items, right? This interval consists of like infinitely many numbers in there.
But in this case, we don't need to like to write them as
Yeah, you should not write these as an interval because we're not given like all those numbers to plug in. We're only given the numbers 0, 2, and 4.
Okay, because they trying to write them as notation, interval notation, but
yeah, so yeah, this one you really shouldn't write that as an interval. It should just be those what they call singleton sets, which is those numbers 0, 2, and 4.
Again, the table. Okay, thank you.
Yeah. All right, so I think that is the first page there. Let's zoom out maybe a little bit. All right, so what do we have next? So this is finding things from the table using this. So like f inverse of 3, we would use this table with the x and f of x. G inverse, this should be a G inverse of 0. 108 is a little bit off. I don't know why there's a 2 there.
Excuse me, you mean 105?
108 has a 2 there that it shouldn't have. But it's not one that's assigned. What numbers are assigned? 105, 109, 121, 125. So I believe 105 and 109 are the ones that are assigned. And we're going to do 121 and 125. So we're doing functions and inverses based off their graph. And so if we do like, let me throw it up there right quick. Where is it at? There it is. All right, so I'm going to do things probably the weird way, but if I do like f of 4 from the table, what would f of 4 be?
It's 2.
It's 2, right? It's this thing right here that I'm looking at. So this represents my x, this represents my y. So if I want to do f inverse and I want to represent the same property, what number am I putting inside of this thing?
Would it be 2?
Yeah, so I got to swap them. So f inverse of 2 would be what?
4.
4.
3.
But if we were looking at the chart, wouldn't it technically be 1? If we're looking at the bottom chart?
We're looking at the f of x. So this is f of x. This one is g of x.
Oh, g of x. Okay, my bad. Okay.
So we're keeping with the same table.
Excuse me, g of x, it works like the inverse function, right?
So The what one equals what?
Is it the inverse function here, g of x, or just the?
No, it's a
product?
separate function. F and G are
Ah,
two
okay.
separate functions. So we get two
Okay.
separate tables. So if we do f of 4, that means we're plugging in an x into that 4, or that 4 is an x. And they want to know what the correlating y is that it's going to spit out. If we do the inverse, now the number that we're plugging in, we should be looking at the y value is what I was trying to get at. And we want to know the correlating x that goes with that one. And so we're talking about 105 and 109. We're going to use a table. We talked about compositions of functions yesterday. So hopefully you write out the definition of this composition of functions to figure it out. That's 105, 109. The other one is 121 and 125 are the last two. It's the same thing. Oh, excuse me, same concept. But now we're doing it with a graph instead of a table. So f of 1, hopefully you go to where x is 1, find the correlating y. If we do inverse, now these should be y values that we're talking about, and we want to know the correlating x. So when we do inverses, they're giving us a y value, and we got to look back at what the x was should have been.
Excuse me, teacher. Here, 109. Which table do we need to use? We don't have any table here, right?
We're going to use both of these tables.
Both those f of x and g of x. Okay.
Yes.
Okay. Thank you.
So if I write out my definition, I'll give you maybe a little bit. F of g of a inverse of 1, right? I think is how this thing looks. Going from the definition. So the first table, I think you're going to use a G table, and then I think the next table you use is an F table. But you got to go the right direction. So try it out.
Okay. Thank you.
All right. So I want to try to finish off this next page within the next 10 minutes or so. Try to get as far as you can. I believe we have 105, 109, 121, and 125 are the 4 that we're working on, right? And like I said, I know it's a lot of problems, but hopefully if you're getting the concept, these things should hopefully not take you too very long. They're not like those rational ones that like you have to like factor it and look at all the stuff, right? Not quite as involved as the rational stuff we were doing before. But like concept wise, it's still pretty heavy, I think, maybe.
Which problems are we doing?
Just basically all the second page, 105, 109, 121, and 125, I believe are the 4 from that page. I believe we covered everything else. 1, 2, 3, 4, 5, 6 of them. Yeah, they did that. Okay. I'm gonna open up groups right quick. Breakout rooms. Okay. Okay. So like 105, did you try anything there?
I don't really know where to start, to be honest, but if you help me work through it, I'm sure I'll understand.
Okay, so this 3 is what sort of value?
Y value?
Yeah, so we're looking, this is the y value of 3. So we're using this thing gives me my f of x. So I'm in like this table. So this table where my y value is equal to 3. Where do you see that?
The second one, when the x value is 1.
Yep, and so this one is
1.
1, that's it. Okay, the next one's a little more complicated. But if we write out our definitions, I think it might help. So I'm looking sort of like I work these things kind of like inside out. So if I'm looking on the inside here, I see this what? G inverse of 1. So now I'm going to my G table. I look along here at my G table. And if I'm doing the inverse, that 1 is what sort of value?
X?
Ooh, inverses, I'm plugging in what?
Oh, Y.
I'm plugging in, this is like a y value here. So I'm looking at my G table when my y is 1. Do you see where that is?
Two. It's on the third slot.
Yeah, right in here. And so what value is that going to give me?
2.
2. So this whole thing that is underlined, this G inverse -1, that's just the same thing as the number 2. So I want to plug 2 in. And now I want to plug 2 in. I'm just bringing things down to my F. And so going back, this is my F table up here. So now I'm using the other table. And the 2 is which value now?
The y value?
Ooh, so that would be if this was inverse.
The x.
This is the right, this is the forward ways. This is just the original F function. So I want to take my F and I want to plug this in where this is like an X value. Do you see that one?
Sorry, could you say that one more time?
Oh, do you see this in the table? Where's my X equal to 2?
On G or y, the third slot, when y equals 5.
Yep. And so this whole thing is equal to
5.
5 should be the final thing you give me.
For me, f of x equals is 4. It's not 5.
Okay, so when we do G inverse of 1, that's giving me the number 2.
Right.
And when I take that 2 and I go plug it back into my F function,
But it's still, you need to reverse it. It's 5.
so the F is going the forward direction.
Right.
If it was F inverse of 2, we would get 4, I think is what you're looking at.
It's 5.
Yeah, so F, the forward direction is 5. Questions about this thing?
I'm a little confused about the layout of this function, like with the open circle and like exactly what it's asking for.
So this is compositions of functions. So when we do compositions of functions, we're basically kind of redirecting things. I think I'm basically doing like that sort of thing, right? I'm starting with the most inward thing and I'm like kind of working my way out. So F of G inverse of 1 should look like F of, and then on the inside we have G inverse of 1. So that is coming from the last section that we just did, where we were combining functions. I'm trying to think of what else. But I'm basically kind of keeping them in this direction that they're defined. I'm just kind of putting parentheses kind of differently, if that helps. Like I keep them in the same order. I just kind of put parentheses and we start with like the inmost way and we work our way out.
Okay, I think I see what you're saying.
Yeah, so I think if you just like throw some parentheses around there, it would probably just help you. We're basically just putting our parentheses in a slightly different way and we're working our way out. So it's kind of weird when we do compositions of functions because usually we're reading things like that way, right? And we start with the things that's the leftmost and we start reading right. The thing that I think trips people up with this is that we're actually read our compositions of functions inverse of what we usually read stuff. We're starting with the thing that's inmost. And so this is the first thing I see. And then I'm going to do the next thing. Okay. 121 and 125. So F of 1. Who's next? Kathleen, did you get this?
For A, about 110.
I barely heard you.
For A, I got 110.
I'm
Okay,
sorry,
so-
can you hear me now?
Yeah. That's a lot better. Yeah. 110. If they ask for units or something, these are what, dollars?
Yes, dollars.
I can't spell with my mouth. It's hard to spell. That's an A. What's the thing we got really sideways? Starts to look like E. $110. If we do F inverse, oh man, it makes this one really easy, hopefully. What's the inverse of 110?
Ten. But where did you get this 10? Sorry. Sorry, it's my bed. Okay, sorry.
All right, so we're looking at the graph itself, right? Maybe if I like zoom in on this graph, it might also help. So let me get a good
for
zoom
the
in.
f of 1, how it's f of 1.
So we're looking where f of 1, this is my x value that I'm plugging in. So
Yes,
I'm
it's
plugging in an
110.
x. I'm plugging in an x value of 1. The correlating y value is 110.
110, okay. Then now we're looking for 1. Okay.
Now, if I go the other way around and I want to do an inverse, what's f inverse of 110?
It's 1.
1 year.
Yep, 1 year. Yep. What's the inverse of 160?
And then 5 years.
So hopefully you're looking along here where it says 160 and the y, and you're looking at that x that says 5. That's it.
Okay.
Like I said, these things will like take you, they'll take you a second if you know what you're looking for. Hopefully. Questions about this one?
Do we have to put like the dollars and the years on it, or can we just put the numbers?
It really depends what it says. I think here we're probably okay with just putting the number. If it was a word problem, I would want like this is going to be $110 for 1 year, right, or something.
Yeah.
So knowing what those units are might help you, and it might help you reverse things too. Because if we do the F function, we're plugging in years and getting dollars. If we do the inverse, we're plugging in dollars and getting years. Okay. And the last one on this page. Who is next? Jerry, did you get this one?
Or A?
Yeah, you can just do a few of them, probably. These aren't too.
I didn't get to them, but I could, yeah. Oh, I could do it. Isn't it just 4?
This one, you're not going to go wrong either way, I think, right? It's like 4, 4.
Yeah.
F inverse of 0.
Uh,
Oh, that's cheap too.
0?
Yeah.
It's 0?
Yeah, that's it.
Okay.
This is coming from where the X is 4. I look up here and I look at this 4, right? And I think the other way around is like I look where my Y is 0 and I look at the X also being 0 right here. So it's kind of silly because the point was 4, 4 and 0, 0, right? And those aren't good points to test out to know whether or not you know what an inverse is. F inverse is 6. What is that going to get me?
Is it like 8 point something?
All right. So am I looking at the X or the Y?
Is it the Y?
I'm looking at the Y. It's doing the inverse. I'm looking along here. And I would say probably, yeah, 8.8 or 9, somewhere in that ballpark. That's it. Oh man, F of F inverse of 4.
This one, not really sure.
Oh man, if they tell me F of F, if they give me this on a test, I'm gonna like celebrate. F of inverse of anything. I don't know. I'm gonna just put any. If I take something, I inverse it, and then I go. If I go backwards and I go forwards, the same sort of thing. What am I gonna get on this thing? Anything. Let's say this says anything. f of f inverse of anything, or even the other way around, f inverse of f, right?
What it is before.
It's always whatever you plugged in. So whatever the heck you plug in, that's it. So if I plug in something and I subtract 4 from it, and then I add 4, I'm going to be right back at the thing I started with, right? Same thing, if I subtract 4 and add 4, or if I add 4 and subtract 4, I'm going to be back at that thing. So this thing, f of f inverse of 4, should be 4.
Before.
It should be the thing you started with.
Yes, yeah, it's the same thing because they have the same point.
If we wanted to do it, I guess, with the graph, I want to do my inverse of 4. I'm looking here. It's giving me 4, and then I'm plugging this 4 in, and now I'm going back along here, right? And I'm going back to the thing I started with. So I think I start with the y, I go to the x, and I go to plug in the x, and I go back, and I get my original y I started with. So the first thing you evaluated was probably like the inverse of 4 gives me 4, and then going the forward direction also gives me 4. Questions about this one? All right, so we got one more page to do. This is just tacking on, like, what does 1-to-1 mean? All right, so these are graphs. I don't know. I'm not going to break you out to groups to do these. I want to know first, are these two things functions, 13 and 17?
Yes, 13 is 1-to-1.
13 is a function. How do you know? What's that test we use?
Because the horizontal line and the vertical line take cross once.
Which line test is a function? Which one was that?
Horizontal line. No,
Vertical.
sorry, it's the opposite.
The other one. Vertical line is the function, right? So these
that's
are
right.
functions. That's the first question. Are they functions? We're going to use a vertical line test. So back when we were talking about functions, every x has like one correlating y, right? If we get repeated x's with different y's, that's when it breaks the function. Now, the other thing is determine if it's 1-to-1. Is this 1-to-1? Is 13 1-to-1?
Yes.
And what's the test for the 1-to-1? It's not the vertical line test. It's the It's the horizontal line test. So let me write that up. The function, right? Let's do it with text. That'd be quicker. Function, we're going to do horizontal. No, sorry, I said it wrong. Vertical line test. That's it. 1-to-1. It's kind of similar, but now we're doing a horizontal line test. I don't really like the way this book defines functions or inverses. You can have inverse relations, but the book like completely just acts like it doesn't exist. So it's only has an inverse if its inverse is also a function. It's the way that this book kind of goes.
What did you say? Sorry.
So this book, it only considers inverses if that inverse is also a function.
Okay.
But you can have inverses that aren't functions. In other books, they do talk about inverse relations. This book completely acts like inverse relations don't exist. If it's not an inverse function, they don't consider it an inverse. So is this thing 1-to-1? I'm looking all along here, doing horizontal line test. Is it going to pass my horizontal line test?
Yes.
Yeah, this is 1-to-1, right? So this is a function. This is 1-to-1. Check. Function. Check.
Excuse me, for which number, 13 or 17?
13, right?
Okay, thank you.
Is this a function? Is this 1-to-1? So we already said, yes, it's a function. Is this one one-to-one?
Yes, it's 1-to-1.
So if I do a horizontal line test, is it going to pass it?
No, it's not gonna pass it.
No, it's hitting it multiple spots, right? It's hitting it like 1, 2, 3, 4, 5, 6 spots I can see. If this line keeps going, it's going to hit it infinitely many times. I'll say those words eventually. Use the graph of f of x to determine if f is 1-to-1. The other thing, does it have an inverse?
Yes.
So 13, does it have an inverse?
No,
17, does it have an inverse?
no. Has a multiplicity here, but it
So what's the same thing as saying it has an inverse, or that its inverse is a function? You're on mute if you're trying to talk, actually.
It's saying that that we could flip it, and
Mhm.
it's, yeah, it kind of be the same thing, but not like the same, right?
Yeah, so if we flip it, the vertical line test would be the same thing as the
Or,
horizontal line test. So if it's 1-to-1, does it have an inverse?
yeah,
Yes.
yes.
If it's not 1-to-1, does it have an inverse?
no.
No. So these two things are kind of the same question with the way this book defines things. So if it's 1-to-1, that means its inverse is a function. And if its inverse is a function and it has an inverse, or if its inverse is a function, then it has an inverse. So these two things are really kind of the same question, just asked kind of differently. Questions about this?
So I'm just trying to double check. So if it's not a function, if it's not a function, the inverse is not an inverse.
Yeah, we're not talking about its inverse then.
Okay, gotcha.
The book just completely pretends like it doesn't exist. Other books might do something different.
In this case,
Yeah, it's not one of those
it's
things.
not 1-to-1, right?
So the first one is 1-to-1.
The
13 is 1-to-1, 17 is not 1-to-1, and it does not have an inverse. See, I don't like that because that's a sine function, and sine functions do have inverse signs. We do talk about inverse signs in trig, so that's why I'm not partial with the way the book defines inverses. But if it's 1-to-1, then it has an inverse. If it's not 1-to-1, then it doesn't have an inverse, according to the book. Which one?
Excuse me, teacher. The linear function it's a 1-to-1. Is 1-to-1, right?
So if it's 1-to-1, that means its inverse is a function.
Like when if it's the linear function as 2x, for example, 2x minus 3,
Mhm.
is a function and it's 1-to-1.
Yep, and its inverse is also a function.
It's an inverse. Okay, thank you.
Yes, if it's 1-to-1, that means its inverse is a function, or it has an inverse function. Those two things are synonymous with the way that the book defines things.
Okay, thank you.
This is table's representation of f. Use the table to determine if it is 1-to-1 or if it has an inverse. So when we were doing functions, we were looking for what to be repeated. Do you remember that? If it's got what repeating with different whats? How do you do the function test with like a table?
We had to make sure X not repeated, right?
Yeah, we look at whether X is repeating. So does it have a repeating X? That's how we tell if it's a function. So the other way is if we want to know whether it is what, 1-to-1 or inverse.
Here is repeating. The X is no,
We're going to look for repeating what?
the Y's.
Y's. Okay. So this table is a complete representation of F. Use the table to determine if it's 1-to-1 and has an inverse. So we've already established that's the same question. All right, so go through it. 21, does that have an inverse? Zoom in on it maybe a little bit. It's kind of small, huh? Let me zoom in a little bit. 21, does that have an inverse? Is its inverse a function?
I'm gonna say yes.
Yes. Wait. What are we looking for? Is there a repeating Y here?
Yes, on 2 and 3.
All right. So there's a repeating Y here. So is it 1-to-1 then?
Yes, it's 1-to-1.
If it's repeating,
No,
it's
sorry.
not 1-to-1. Yeah, it failed the test.
I felt very confused.
I think
How
you have it
about,
right.
excuse me, when we have the X equals to 3, we don't have the F of X, the Y's. What?
When f of X is equal to 3, is that what you're saying?
Yes, when X equals to 3.
When X equals to 3, then my f of 3 is 3.
It's 3.
I'm not sure what you're asking.
Yes, because they didn't see it. Or they can see the number. Sorry, thank you.
I'm not trying to delete all that stuff. Okay, whatever. We're looking for a repeating Y. I don't know. I'm deleting that.
In this case, it's not 1-to-1, and
Yep,
it's
not 1-to-1, and it doesn't have an inverse according to this book. 22. Is that 1-to-1?
Yes.
Yep. 23. Is that 1-to-1?
Yes.
Yep, looks like it. No repeating Y's. They're not going to give us repeating X's because they're going to give us something that's a function to begin with. Questions about this? Okay, so it's sort of like what we were doing with the function, but now we're just looking at it kind of backwards. If it's a function and it has an inverse, it's 1-to-1. And sort of like, what does 1-to-1 mean? Well, I don't have any X's that repeat, and I don't have any Y's that repeat. So each X has a unique Y, and each Y has a unique X. Right, that's what they mean. For every one X, there's exactly one Y, and for every one Y, there's exactly one X that matches up with it. It's a unique pairing.
and we can say it's the 1-to-1. If we have one point, it's like has two inputs. We can't say it's 1-to-1, right?
No, yeah, but they're not going to do that because that's going to break the function definition of the original thing. So yeah, so they're not going to repeat the X's, and then we have to check if the Y's repeat, right? And so none of the Y's repeat, then each X has a unique Y, and we can say it's 1-to-1. Questions about that?
And excuse me, teacher, for each X has only one Y, and at the same time is an inverse function, right?
So if each X, well, if an X has multiple Y's, then it's not a function.
Yes, this one, yeah. I'm asking about for each X has only one. Like if each X has only one Y, right? This one is the 1-to-1. And we can say it's an inverse function, or is the same thing?
So if we had an x that had two different y's, right?
Yes.
Like a 2, 1 and a 2, 0, this would break the definition of the original thing being a function. So they're not going to give you something like that. They're going to give you something that is a function to check. And so I don't think we have to worry about repeating x's, but you want to recognize that they're not repeating, right?
For each of them, the y's and the x's has only 1 point, so doesn't.
Yep.
Like,
And we're not going to have a repeating y.
Correct.
So like this can't be like 4, 5, 4, right?
Okay.
And we're not going to have something like this. So each x has a unique y, and each y has a unique x.
Perfect. Thank you.
And so that's what makes it 1-to-1. We don't have repeating x's and we don't have repeating y's. All right, so we have a few more. What's the time? Determine whether it's 1-to-1. You may use the graph. Okay, so I want y'all to think about this. Which ones have we got? We're on 31, 41, 71, 137, and 150. 31, 41, 71, and 150.
For the 71, we just
137.
need the graph, right?
Yeah, so I want y'all to think about these. I'm probably not even going to open up rooms because we got like 8 minutes. But 31, 41, what were the other numbers? 31, 41, 71, 137, 150. So this one, if you know what the graph looks like, that would probably really help. Decide if this is a 1-to-1 function.
For the absolute value?
For absolute value for 41, they say the US population from 1980 to 2010. So they're trying to give us some word problems to maybe throw in there and think about what a 1-to-1 function means. Checking symbolic skills. This is a little weird. Restrict the domain so that it's a 1-to-1 function. Then find the inverse. We'll talk about the domain thing that they're talking about. The main thing is like try to find the inverse with this thing, I think. And then 137, they want us to graph this thing and to graph the inverse. So we will talk about how to do that a little bit. And then 150 is a word problem. Okay, so inverse or absolute value. What does an absolute value look like?
It looked like a V.
It looks like a V. I know that this is my function. This shifts it to, I believe, -1 shifts it to the right one, maybe.
Yes.
So I know I have something that looks like a V, I think is the important thing to take away. And if I have something that looks like a V, it's going to pass the vertical line test. So it is a function. But the question they ask, is it 1-to-1 or does it have an inverse? What do they say? Determine if it's 1-to-1 or has an inverse. Does it pass the other test?
No.
No. So if we do a horizontal line test, right? It's
Yeah.
not going to pass the horizontal line test. It's going to hit it at more than one spot.
It's not 1-to-1 in this case.
So it's not 1-to-1. There is not an inverse function for this thing. What about the population from 1980 to 2010? If you were to imagine what that looks like. What's the population in the US? I imagine, yeah, US population from 1980 to 2010.
It's increased.
It's increasing. You think it's ever going to go down?
Yes, it will go down.
Like down?
No, oh,
No, up, increase.
No, it's gonna go up. It'll go up at maybe at different rates, right? Maybe we'll have a jump here or something. But it's just all gonna go up and up. And if it's just going up and up, what does that mean about this? Is it 1-to-1? Will it pass the vertical or horizontal line test
Mm,
if it's going up the
yes,
whole
it's
time?
1-to-1 because it's going up and yeah, it's 1-to-1. I want
Yeah,
to
it's
say
not
so.
gonna. Yeah, it's all going up and up and up. It's never gonna level out. I mean, there's people being born, there's people dying, but there's more people being born than there are people dying, right?
okay. See, that's what I was thinking. I was thinking about what about the people who passing away? So that
Yeah.
one, like, okay, it's gonna go down.
Yeah, but
Okay.
there's always gonna be more people born than what are getting passed away. And so overall, if we average it out, it's just gonna go up and up, right? Up and up, up and up and up. And so that is 1-to-1. That is 1-to-1. Okay, this is the thing that they're talking about. Y equals 4 minus x squared.
This one is a parabola.
So this is the same thing as a minus x squared plus 4, I believe. Might be the
Yeah.
better way to look at it.
It's going down.
Yeah, and so it's a flip parabola, and I think it gets raised up 4.
Yes, and it's open down.
And like here's the 4, it's opening downward. So we want to restrict this thing so that it is 1-to-1.
No.
That's kind of a weird thing to ask, but you should be able to do it, maybe. Where would you cut this so that it's 1-to-1?
In 4. 1y equals to 4.
Yeah, right here on the vertex, right?
Right.
And so if we cut it on the vertex where it's symmetric, and I'm going to cut the negative half off probably. What's my domain for that part?
The domain is minus infinity plus infinity.
That's for the whole thing. If I cut it at the vertex,
Would it be 4 in infinity?
not 4. What's the number for the x here?
0.
So x has to be what, greater than or equal to 0?
Yes, it's 0 plus infinity.
So they're basically asking you just to take like the positive half of the parabola. And if we do that,
Do they give us the it needs to be greater than 0?
so the domain should be that x is what, greater than or equal to 0. And so that will restrict our parabola. So yeah, so 0 to infinity is another way we could write it. Yeah, that's it.
But how for the range? Because it's minus infinity 4.
Yep, the range would be minus infinity to 4. That's it.
Okay.
Which might be good to talk about because when we do our inverse, we're going to basically just flip these things, right?
Yeah, it's 4 minus infinity.
Okay. So if we're trying to solve this thing, trying to do the inverse.
For the same. Okay.
Yeah, so minus y squared plus 4, I swap them and I solve. So this is going to be x minus 4 is equal to what, minus y squared. I have to multiply everything by a negative x plus 4 equals y squared. And now I think this is where that domain restriction comes into play. Because when we take a square root of y squared, we want to make sure it's positive, I believe. And so if we want just the y by itself, it should look like y is what, square root of a negative x plus 4.
Yes, it's a square root of x minus 4.
they're doing something very similar with this one,
Mhm.
except now we have a x plus 1 in parentheses. I think we're gonna have to take the square root first and then do the subtraction. I think we're gonna get something that looks like y equals square root of x minus 1, I think is what we're gonna end up getting here. I did that in my head real quick. And so that should be the inverse. If we want to graph this thing, x plus 1 squared is a parabola moved to the left one. So we have one that looks like a parabola, not. And this is the root x minus 1. This looks like that positive square root coming, something like that. And then the other thing they ask us to graph is the y equals x line. And so the y equals x line is basically that 45-degree line that goes down your axis. And so what they want you to notice is that this thing is reflective. When you do your inverses, it's basically a reflection about the y equals x. Questions about this? We are at time. I got to stop here.
It's not so much of a question. It's like I understand it, but I feel like what kind of getting me lost is when I need to do the domain and range. I'm not gonna say kind of getting me lost, but that is like what kind of throwing me off.
So are you talking about like restricting the domain here?
Oh yes, restricting the domain.
They're basically cutting this parabola at the vertex is what they're doing. And so there is more to this parabola here, right? Same thing with this. If I look at this one, there's more to this parabola here. But they're basically deleting everything that's to the left of the vertex. They're figuring out the x coordinate of the vertex. So my x coordinate of this vertex would be what? -1, 0.
Yes.
And so basically I want everything that is greater than or equal to my x coordinate of my vertex to split my vertex in half. Those are kind of weird questions. I think usually if we ask for domain restrictions or something, I think we usually give them to you.
Okay, thank you so much.
Okay, let me.
All right.